It's fierce. It's impeccable. And it might just obliterate the competition for good. Wondering how Musk achieved this and what it signals for the future of transportation? Buckle up. The journey begins now. Tesla has rewritten the playbook for electric motors. For years, they've spearheaded the electric vehicle race. But this time, they've done something far more groundbreaking. Rather than refining an existing blueprint, they've introduced a motor so cutting-edge it could render all others outdated. This powerhouse can propel a 2-ton car from 0 to 60 miles per hour in just 2 seconds. The first hint of this marvel came during the Model S Plaid delivery event on June 10, 2021, when Musk casually showcased a drive unit so compact a single person could lift it, yet potent enough to thrust a full-size sedan into supercar territory. At its core lies a rotor enveloped tightly in carbon fiber. It might not sound thrilling at first, but the impact is monumental. "There's never been an electric motor like this," Musk remarked. "You could lift it with your hands." Traditional electric motors suffer as metal parts expand under heat, degrade under stress, and eventually fail. This caps their speed and durability. Tesla overcame this by crafting an in-house technique that wraps carbon fiber around a copper rotor at extreme tension. This outer layer secures everything, keeping the rotor compressed and maintaining a razor-thin air gap between rotor and stator. This boosts efficiency and magnetic force in unprecedented ways. Thanks to this innovation, the rotor remains stable at astonishing speeds, over 20,000 revolutions per minute, surpassing the 16,000 RPM limit where most high-performance motors falter. Motor Trend confirmed these speeds in tests, noting Tesla's design operates nearly 25% faster than its prior generation, a remarkable leap in electric motor engineering. What does this mean? A motor that delivers greater torque, stays cooler, weighs less, and withstands more strain without squandering energy. This isn't just an improvement. It's a complete reinvention of how electric vehicle motors are constructed. The RPM is so wild that centrifugal force alone tries to expand the rotor, Musk explained. Tesla didn't stop at performance. They mastered production too. Each Model S Plaid houses 3 of these motors, generating a combined 1,020 horsepower and 1,050 pound-foot of torque. Yet each unit is small enough for one engineer to handle during assembly. At Tesla's March 2023 Investor Day, they revealed the next generation of these drive units will eliminate rare earth elements, use 75% less silicon carbide, and cost roughly $1,000 to produce, an industry-shaking figure. The performance is staggering. 0 to 60 miles per hour in under 2 seconds, making it quicker off the line than nearly any car in history, including Bugattis and Lamborghinis. Independent tests clocked the Model S Plaid at 1.98 seconds to 60 miles per hour and 9.25 seconds in the quarter mile, with a top speed of 200 miles per hour once software restrictions were lifted. But it's not just fast, it's efficient. Older high-performance EVs drain batteries like rocket fuel. This one doesn't. It channels power into motion with minimal loss, requiring no oversized radiators or intricate cooling systems, just clean, consistent output. It's, what's the word, dangerous, Musk quipped. EPA data supports this. On 21-inch wheels, the Model S Plaid achieves 348 miles of range and a combined 101 mpge, roughly 33.4 watt-hours per mile. Impressive for a car with over 1,000 horsepower. Real-world tests by Inside EVs at 70 miles per hour showed the Plaid still managed 300 miles on a single charge. This motor delivers blistering speed and long-range endurance, solving the EV trade-off between power and range. Now you get both, ferocious acceleration and practical efficiency. No compromises needed. Tesla's delivering this at scale. And thanks to simpler designs, lower material costs, and reduced complexity, their production costs have plummeted. Whether they pass those savings to buyers or retain the profits, the advantage is theirs. When you leap this far ahead, competitors don't just lag, they collapse. Tesla's rivals are slipping further behind. And quickly. Not long ago, the EV race seemed neck and neck. Major automakers like Ford, General Motors, Toyota, and Volkswagen were investing billions, while startups like Lucid and Rivian promised bold innovations. China's BYD was leading global sales for a moment. Tesla's dominance seemed at risk. Then came the carbon-wrapped motor, and the game changed. Most legacy car makers still build EVs on platforms designed for gasoline engines, making their vehicles heavier, less efficient, and costlier to produce. Their factories, built for gas-powered cars, rely heavily on suppliers for critical components like batteries. Tesla, however, designs every vehicle from the ground up as an electric car. Their factories are purpose-built for EVs. They produce their own batteries, and now they've created a motor no one else can match. While competitors struggle to catch up to Tesla's last breakthrough, Tesla's already moved on to the next. Take Ford. They've pledged $50 billion for EV development through 2026, but their Mustang Mach-E SUV is over 300 pounds heavier than Tesla's Model Y. Ford's EV division lost $1.3 billion last quarter alone. General Motors, with $35 billion committed to EVs by 2025, has faced delays with its Ultium battery tech due to software and robotic assembly issues, forcing costly manual work. Toyota, after investing $38 billion in EVs, is pivoting back to hybrids due to slower than expected EV demand. Their BZ4X has struggled to gain traction. Volkswagen's software division, CARIAD, has lost over $7.5 billion since 2022, leading to layoffs and delays, including with the electric Porsche Macan. Startups face even steeper hurdles. Lucid's Air sedan is among the fastest EVs, but costs around $150,000. With only 9,000 units built in 2024, and despite a 70% delivery increase to over 10,000 units, Lucid lost $3 billion last year and relies heavily on Saudi funding, which owns over 60% of the company. Rivian, known for electric trucks, built nearly 50,000 vehicles in 2024 but fell short of goals, reportedly losing $40,000 per vehicle. Even after a positive gross profit quarter, Rivian expects billions in losses in 2025. BYD, China's EV giant, delivered over 4.22 million plug-in vehicles in 2024, claiming 18% of the global market, but most are low-cost hybrids or compact EVs priced under $25,000. And outside China, BYD faces trade barriers, exporting only 240,000 cars last year. Tesla's edge isn't just motors or batteries, it's software. Their full self-driving system, trained on over 3.6 billion real-world miles by early 2025, dwarfs General Motors' Super Cruise, which has logged 300 million miles. Tesla's AI improves constantly through real-world feedback, with updates rolling out every few weeks. Most competitors rely on simulations or closed-course testing, slowing their progress. Tesla also produces its own 4,680 battery cells in Texas and Nevada, which are more energy-dense and cost-effective, enabling seamless vehicle integration, something rivals dependent on suppliers like LG or Panasonic can't match. Then there's scale. Tesla builds advanced tech faster and more efficiently, leading to better margins, quicker innovation, and reliable delivery. But Tesla's dominance isn't just about tech, it's about an empire built to sustain it. Tesla isn't just crafting superior electric vehicles, it's producing them smarter, faster, and in more places than anyone else. While other automakers grapple with supply chain delays, battery shortages, and outdated factories, Tesla is forging a different path. It's not waiting for the market, it's shaping it. It began with a bold move in China. The Shanghai Gigafactory transformed from an empty lot to a functional plant in under a year. Today, it produces over 750,000 Model 3 and Model Y vehicles annually. Uniquely, Tesla fully owns this factory, a rarity for a foreign automaker in China, granting complete control and profits. Expansion continued westward. Gigafactory Berlin opened in early 2022, hit 500,000 Model Y units within years, and is producing nearly 5,000 vehicles weekly, faster than Volkswagen's nearby EV plant. In the US, Tesla's Austin Gigafactory has surpassed 400,000 vehicles and can build over 375,000 cars yearly using massive gigapresses that cast car frame parts in under 2 minutes. Combined with the Fremont factory, Tesla's US production capacity nears 1 million units. Musk isn't slowing down. In northern Mexico, Tesla secured land for a new Gigafactory near Monterrey, with plans to invest up to $10 billion and create 20,000 jobs. Production could start by 2026. Meanwhile, Tesla is entering new markets. In early 2024, they opened their first South American location in Santiago, Chile, a showroom, service center, and supercharger hub. In April 2025, a flagship store and service center launched in Riyadh, Saudi Arabia, with more planned for Jeddah and Dammam, aligning with Saudi Arabia's Vision 2030 goal for 1/3 of its capital's cars to be electric. In India, Tesla began talks in March of 2025 to sell imported vehicles and build a local factory, meeting India's EV policy requiring a $500 million investment within the country. The discussions have included potential tax breaks and supply chain partnerships that could pave the way for a gigafactory in India, one of the world's largest emerging car markets. If successful, this move would mark a massive expansion of Tesla's global footprint, giving the company a strategic base in South Asia and access to a population of over 1.4 billion people. It would also signal Tesla's readiness to adapt to localized manufacturing mandates, which are increasingly common in large international markets. All of this expansion, whether in China, Europe, the Americas, or potentially India, is part of Musk's broader vision of Tesla as a vertically integrated, globally scalable powerhouse. Unlike legacy carmakers who outsource much of their manufacturing and rely on slow, fragmented supply chains, Tesla does nearly everything in-house: design, engineering, battery production, AI development, software, and now even gigacasting. This reduces costs, shortens lead times, and gives Tesla the agility to innovate and pivot at speeds competitors simply can't match. And there's more on the horizon. Tesla's future lineup includes the long-awaited Cybertruck, which will debut with the same carbon-wrapped electric motors and full self-driving capabilities. Initial production has already begun at the Austin Gigafactory, and the vehicle promises to redefine the electric pickup market with its stainless steel exoskeleton, adaptive air suspension, and bulletproof windows. In testing, it has demonstrated capabilities that rival traditional trucks while maintaining the lightning-fast acceleration Tesla is now known for. Meanwhile, Tesla's upcoming $25,000 compact model, often referred to as the Model 2 in media circles, could become the company's most disruptive vehicle yet. Slated for production by 2026, this affordable EV would open the brand to millions more customers, especially in markets like India, Southeast Asia, and Eastern Europe where price sensitivity is paramount. Tesla plans to build this car using their next-generation unboxed manufacturing process, which will slash production time and cost even further. On the energy front, Tesla's ambitions are equally bold. The company is ramping up deployment of its Megapack storage systems, which can store massive amounts of renewable energy to stabilize power grids. In 2024 alone, Tesla installed over 15 GWh of energy storage globally, more than any other company. Its solar roof division, while slower to scale, continues to show promise, especially in California and parts of Australia. All of this, the advanced motors, revolutionary batteries, software supremacy, rapid production, and global scale, is converging to make Tesla not just a car company, but a dominant force in the future of transportation and energy. It's not simply that Tesla is ahead, it's that it's playing a different game. While rivals try to retrofit old systems and architectures, Tesla builds a new, faster, cheaper, smarter. And in a rapidly electrifying world, the difference could be the deciding factor between leading and becoming obsolete.